Today we're going to look at a slightly more involved factoring problem for a difference of two cubes. We're going to factor the polynomial 27x cubed minus 64. We know we're using difference of cubes because we're subtracting these two terms, and both terms are perfect cubes. We have 27x cubed and we have 64. So you can take the cube root of both of those is maybe a way you could think about it. So we want to recall our template, especially if you're new to this. We're going to follow the form a cubed minus b cubed. Link in the video description to the video that goes through this template in detail if you'd like that. Right now we're just going to recall it. Remember, we factor this into a binomial and a trinomial. I'll put in the terms and then the signs. We'll use the SOAP acronym to make sure we get the signs right. So we have a and b make up our first binomial. And then we have a squared, ab, and b squared as our trinomial terms. SOAP is our acronym that tells us what signs to put to connect these terms. So we have SOAP. The S stands for same as your original polynomial, so in this case it's a minus sign or subtraction. The O stands for opposite, so connecting that a squared and ab term, the opposite of subtraction is addition. We'll put a plus sign. And then the AP helps us think always positive. So connecting that AB and B squared terms, and those terms in the trinomial, it will always be positive. All right, so we've got our template recalled. We just need to define A and B for our particular polynomial, and then we can sub into the template. So to find A, you really can just take the cube root of that first term, that 27x cubed. So cube root of 27, of course, is 3. Cube root of x cubed is x. And then for the b term here, don't let yourself be swayed by that minus sign overcomplicating the template. SOAP and the template have already accounted for all the signs. We just want to take the cube root of 64 here, which we know to be 4. And now we can sub into our template. All right, so here's the binomial. Here's the trinomial. All right, so our binomial is made up of a minus b. Remember, same is that sign, so it's a difference. So we have the same sign as our original problem, 3x minus 4. And then we're going to fill in our trinomial. So be careful here, opportunity to make a mistake. People forget to cube the entire term that we've defined for a. Sometimes people will write simply 3x squared, but remember you have to square the 3 as well. So just showing that right there. That'll be 9x squared as the first term in our trinomial. And then the opposite sign is the original, so that's why we put that plus sign there. Just looking up at our template. A times b will be 12x. And then always positive for that last sign. And then 4 squared is 16. So this is our factored polynomial. A quick reminder, you'll never be able to factor that trinomial further. That actually gives you two complex solutions or with imaginary parts. So if you're solving, you'll simply use your quadratic formula for that part. Don't spend any time trying to factor that further. That's as factored as it will get. All right, so this is your answer. If you do want to double check yourself, you can take a moment to do that. All you have to do is multiply these two polynomials. All right, so we have 3x times 9x squared, that's 27x cubed. 3x times 12x, that's plus 36x squared. 3x times 16, so plus 48x. All right, moving on to that second term in the binomial, we have minus 36x squared. We have minus 48x. And we have minus 64. So you should be feeling really good. You see that multiple of your terms cancel to 0, and we're left with 27x cubed minus 64. So this is confirmation that our blue factored version is the correct way to factor our original polynomial. So hopefully this helps you feel confident in using this difference of cubes method. Just practice a little bit with it. The more problems you do, the more comfortable you'll get, and the quicker you'll be. Thanks for watching.